So hello everybody, welcome back to the live stream where we learn C++. So today we are in day 20. So thank you for sticking together with me in this journey. So thanks to everybody who has been uh, a part of this journey up until here. And let's just continue. Uh, all right, so today we will um learn about recursion, which is a very interesting topic. I'm sure you must have heard about recursion somewhere in college or um, you know anywhere on the internet at least. But let's learn about recursion. Maybe you might have come across some memes related to recursion, etc. So let's really look into what recursion actually is today. So here is an introduction. Um, so what is actually recursion? Uh, Here they said it is a process in which a function calls itself directly or indirectly. Uh, Alright, it's called recursion, and the corresponding function is called recursive function. Alright, so which is basically just a function that calls itself directly or indirectly. All right. And here, a recursive algorithm takes one step towards solution and then recursively calls itself to further move. The algorithm stops once we reach the solution. All right. Um, so that is what it means. Now, let me just close this. All right. I think it's just what is going on here. I'm not able to highlight. Let's just. All right, if you're just here, welcome to the live stream. We are learning about recursion today. So, uh, give me a minute. Let me just check what's going wrong. All right, there is something that is going wrong. I'm not sure what it is. All right. All right, all right. I think we can continue. Um, let me just see. Okay. All right, I think we are good now. Okay. So let's just continue. So we just defined recursion. It is a function that is calling itself directly or indirectly, and it calls recursively calls itself, right? Um, and stops once we reach the solution. Okay. Um, okay. So this here, since call function may further call itself, this process might continue forever. So it is essential to provide a base case to terminate this recursion process. We'll look into all those things. So here, instead of just looking at these definition, let's say, okay, step one, we have to provide a base case. Step two, define a recursive case. And then you have to ensure the recursion terminates. And you have to combine all the solutions. The last. So let's just go into an example and let's test it by ourselves. instead of going through definitions, here, this is a little bit of here if you see sum of natural numbers. This is one example, but first let us do a normal example, like a simple one. All right. Um, so here, if you see, I have defined a function func. All right. And then here, if you see, I've called this function itself again recursively. So func, I've called it again inside here. So I define function, and then I call that function again. Yeah, it's the same function. All right. And look at the argument I passed. I have defined n here, integer, and then here again I just said n minus 1. All right. So if you see what is going on here, um, here let us say, for example, there I did not. If you wonder what this is just the base case. But let us say we did not provide this. We did not provide this. All right. Then what would happen? Like, let's say that is not there. For example, now I removed it. What would happen now? Let us see. Let us just run this now and see what happens. Let us see. I'm just going to run this program, recursion, compiling. All right. Uh, See, it is not even stopping, right? This just keeps going, right? Let me just force stop it. See, it just went on up till like 1000 to 1021. All right. Look at how much numbers it printed on the screen here. If I didn't force stop it, it would have just kept going. Look at this. My terminal itself crashed. I can't even go up. So look at this. So let me just, for your understanding, let me just not crash my terminal, but let me run it again. But this time not crashing it, stopping it very quickly. All right, now here, can I go all the way back? All right, okay. All right, now you see, I found the start. So here, it starts from 5, which is what we wanted when we pass the function here. We wanted it to start from 5. All right. Then it kept going down and down and down, which is what we said, n minus 1, right? So then kept going down, down, down. And what happened here? And when it hit, if you have just joined, please like the video. It helps, it helps the stream to reach to more people, and that would help them as well. So please do like and share also if possible. And let's continue. Uh, so here, what happens? We didn't want the cases after this, right? We wanted only to print up till 1, right? So why these got printed here, right? We want only to print from 5 to 1, but it just keeps going here, right? That is because this is recursion, right? It just keeps going, right? Until it keeps running until and unless you provide a base case for which it should stop. All right. Otherwise, it just keeps going. For example, here, what is this case here? This is the case when n is equal to 5. Similarly, when n is equal to 4, 3, 2, 1, and when 0 hits, right? We don't want the 0 to be printed. So what we do? We just have to provide that condition over here. which is the base case. If n equal to 0, if n equal to 0, what do we have to do? If n equal to 0, just return, right? Just return. That's it. We want it to end. That's it. Want the program to end. So just define it over here. That's what we did here, right? If n equal to 0, return. That's it. And then see out. That's all, right? So now let us see what happens. Now let us see what happens here when we run this program again. All right, now let us see here. All right, so here again when we run, see now it just stops. It didn't go after one. Like because why? Because we provided this base case over here. This what we wrote here is called as the base case. Base case. Base case. All right, this is the base case. What is this? This is the recursive case, right? This is the recursive case. Recursive, recursive case. So these two are over, base case and recursive case. Have we ensured the recursion terminates? Yes, we did, right here. And yeah, so that's what all the steps we completed. So here, this is where we have the purpose of recursion. Here we use any loop for loop to print? Use typically would use a for loop, right? To print numbers here. Here, another thing you would notice is we printed the numbers backwards from 5 to 1. Now, what would you do if you want to print the number forward in ascending order? 1 to 5. Simple, right? What do you have to change? You have to just change one thing. If someone has here, please let me know if you know what to change in this code. In this code, what to change if I have to print the numbers in ascending order from 1 to 5. Not like this, not from 5 to 1, but from 1 to 5. If someone is here, please do let me know. Um, if you're following along, that is good as well. But yeah, I would like it to keep it interactive. So if you're here, please do let me know. And if someone is just joined, drop a hi. And if you have any questions, please do ask me. I will check it when I look at the chat. So keep asking your question. So yeah. So here, I hope you got what you should be doing here. If you have to print it in ascending order over here, it is simple. Let us just, instead of doing it this way, here, I have to just say, let us see what happens now. Let us see what happens now. All right. Let us see. I saved it. All right, all right, all right. Let me just, okay. So here, let me see. Uh, Okay, can't see out there. All right. So here, if we want to print in ascending order, what do we have to do? Here, I am just going to, let us say, okay, all right. Here we did return from 5, all right. Let me see, let me see what happens over here. Uh, all right, not there. If you have any ideas to print it in ascending order, please let me know. Uh, any ideas? I want this to be printed in ascending order, not like this, not descending order, but in ascending order. So how can we do that? It just needs a small change in this code. How to do that? All right, so here, um, let me just, all right, here you can see, okay, there is different things over here. All right, there's many programs regarding recursion given over here. Let me just verify this. Let me just verify this. Uh, okay. All right. So here we have. Okay. So here, let me just move this up. Let me just move this up. Um, or let's just keep it like that. Let's just keep it like that for now. Let me see. Let me see how we can go about this. Right. So here for factorial finding, it's very useful. All right. So let me just ask. Uh, change this code to print in ascending order, ascending order. All right. So let me see. Let's see for the explanation. All right. So here we are printing before the recursive call. Yeah. So didn't we try that before? I'm not sure. Did we not try this? Okay, maybe we printed after everything. So basically, you just have to print after this recursive call. Then you will just get it in ascending order. All right. Thought we tried that before, but all right. Let me just, all right, let me just compile. See, now we have these in ascending order. What we have to do is just one small change. Print this after this recursive call. Recursion happens here, and after that, you just print. All right. So now we can just simply modify this program to find the factorial of a number, etc., whatever you want to do. Let's see how we can find the factorial. If you have the formula, you can just use it to find the factorial. So here, if you have this formula is for finding sum of natural numbers, right? The sum of natural numbers is basically just this, right? This is the sum. Okay, not that actually. Um, okay. I'm just trying to find. Okay, all right. So here there is a recursive call, right? Here there is a recursive call that's going on. All right. So n plus sum of n minus 1. So this is the recursive call. Here, instead of doing it like this, you can also store this in a result variable and also just return that. All right. Return n plus result, right? So that is also possible. So that is a very simple one. Just to find the sum of natural numbers. All right. So that is, I don't think we need to do that. Uh, Comparison of recursive and iterative approaches. Need for recursion helps in logic building. All right. Um, Solving complex problems by breaking them into smaller sub problems. Um okay, it is mostly used in dynamic programming, divide and conquer algorithms. All right. Uh, yeah, some popular problems solved using recursion are given here. Very helpful while we are doing data structures later. Okay. What is the base condition in recursion? All right. This is where the program stops. There can also be more than one base conditions. All right. So, yep, that is about that. And here, finding the factorial of a number. Let us just change this program to find the factorial of a number. So if you have to find the factorial, what is the formula? Right? This is the formula, right? for finding the factorial of a number. Let us just formula for finding the factorial of a number. Factorial of a number. All right, so here you have this formula. Um, n into n minus 1, right? This is the formula. So that is n factorial, right? So now just if I had to just change this program into program that finds the factorial of a number, I can just say here, let me just comment this part. I'm just going to change this into finding the factorial of a number. All right. And I'm just going to change this. Base case, what is the base case here? Um, let us see. Let us keep it as it is for now. What is the recursive case? Recursive case is here. What do we have to return here? Um, what is the formula as you can see here? N into n minus 1, right? So let us just change this to n into n minus 1. All right. So this is what I'm doing here now. And C out n. All right. And we do have a base case. Let us keep it as it is. We'll see what happens. Uh, so let us find the factorial of, for example, 3. Factorial of 3. So what happens? Let's see. Or maybe let's do for 4. Let's find factorial of 4, right? So this is the factorial we have to find. Here, let's see what happens. Um, let's just see what happens. We need to find the factorial of 4. This is not the exact program to do that, but let's see what happens here. Uh, so as you can see, all right. So wait a minute. So here, nothing happened actually. Look at this. It just stops for some time and then nothing happens, right? Why is that the case? Because here, what did we do? We just, here it starts itself. All right, so here we have the recursive case, which we defined here. All right, now let's see. Now let's see if we remove this from here and we put it here. Now, what has happened? Now look at this. It just keeps going, right? Uh, and look at the values got printed here, over here, if you notice. All right. 4, 12, 132. See all these values that got printed. Now, are you able to identify what these values are? Are you able to identify what these values are? What is 4? What is 12? What is 12? These are just, we didn't do this correctly, right? Let's see what is going on here, actually. Look at this. Let's do a dry run of this. Dry run this. Look at this here. Here, first, it is checking n equal to, we gave n equal to 4. Here, n is equal to 0, no. Goes to the recursive call. This is the recursive call we gave. Alright. This is the recursive call. So prints 12, which is what happened here. Prints 12. Alright. Then again, what happened here? Why did it print 132? What happened here? Now it went in again. That value 12, right? What we got from 12. Like what we got from the previous iteration, right? That value goes into this function again, which is what is recursion. So again, what happens here? It becomes 12 into 11. 12 into 11. Why is it 12 into 11? It is, as you can see here, this becomes 12 into 12 minus 1, like here. So it becomes 12 into 11, right? So now again the same thing happens. 132 is called. This becomes 132. From 132 is called again. Same thing keeps going on and never stops. So look at this. Eventually an integer overflow happens, right? Because integer can hold up to only the value plus or minus 2.1 billion, right? So either that happens or what happens? So here, even after the overflow, the value is extremely unlikely to become exactly zero. So the base case is never reached, right? So here, it just keeps going, right? So the base case is never reached, keeps going, right? So why does it not stop? Your base case is zero here, but you are doing this, okay? It's saying this, right? Now, for positive n greater than 1, the value gets larger, not smaller. Alright, so n greater than 1, for n greater than 1, right? The value just keeps getting larger, right? It never stops. So recursive function should move towards its base case, not away from it, right? Here in our case, it just goes away from the base case, which is equal to 0. That's why this overflow happened, right? Or eventually that will happen if this keeps going. So what should we do? What should we do instead? Instead, what should we do? instead of we do not need to do this, right? Do not need to do this because that just prints the number. We just have to print the factorial. So print factorial, right? We do not need this. So this is what we should do to print the factorial, right? So here you have the recursive case, all right? So let us just remove this. This is not how we should do it, right? Because inside the function itself, we are calling this, right? Which is not what we have to do. We need a new variable, let's say result variable, and let's just say n into what is it? Function of n into function of n minus 1, n minus 1. All right. So we are storing that in a result variable, and after that, in the result, and after that, we are printing over here. We are just going to return a result over here. All right. We're just returning result. The base case is what? The base case is what? Base case is if n equal to 0 and or, this is or actually, not and. If n equal to 0 or n equal to 1, return 1. So shouldn't overflow. So that's why we give that case n equal to 0 or n equal to 1. We are saying not return 0, return 1. Why return 1? Return 1, why? Not return 0. Instead, we are saying return 1, which is actually what? Return 0 is what? Return 0 is to terminate, right? Return 1 is, that is what we should, that is what should happen. That's the case that should actually print, right? So we are keeping it inside our range. All right. We are not saying um, we don't want this. We are saying that's what the value we need over here. All right. So we have this range over here between 0 and 1. All right. We're just keeping this range, strict range. All right. So it won't overflow on either side. Right. So let us just run this over here. I think we are good. Let us just run this over here and see what we get. Let us run and see what we get. Let's see if we are able to find the factorial. Let me just clear this terminal. Let's just go down. Right, we are able to go down. Okay, so now let me see if we are able to find the factorial of 4. And let me just save it. All right. So now again, it didn't print the factorial of 4. It just printed 432, right? It didn't print the factorial of 4. There is something additional that needs to be done here, right? Um, okay. All right. So here, what happened over here? I think it's fine. Okay. It looks all right. Let me see. Okay. So let's also return 0 here. Return 0 here. Let's see. Still prints 432. Okay. So there is something that needs to be done. Here we are returning result. Um, yeah, we did return result over here. But we are not printing result, right? We are returning result. So let's print. Okay, that is something we have to do, I guess. Uh, or do we need to even print it over here? I don't think we need to print, right? Let us see. Let's not print. Let's not print. Let's see. Okay, now let's print it over here. See out result. Let's just print after this. Okay, see out result and I don't think this is required, but let's see what happens. Again, it doesn't do much. So there is something that has to be done over here. Return result. Let's not print anything. Let's just return result. That's it. Again, nothing is done. Something is wrong over here. What is going wrong here? I have some. Oh, all right. I think here, how can I return func and then return 0 again? Can't do that, right? Okay. All right. Let me just see out func. Okay. See out func. Oh, okay. How can I return? How can I just return two things? All right. Now I think we are fine. Now let's see. Um, yeah. So we got the answer here. 24, which is what we needed, I guess. Is 24 the answer for factorial of 4? Yes, it is. 24 is the factorial of 4. Now, just to verify, let's do for 5. Let's do factorial of 5. All right. Okay. Now we got 120. Is that the factorial of 5? Is that the factorial of 5? 120. Yes, it is. 120 is the factorial of 5. So, yeah, we got this correct now. So let's just see what happened here. Um, let's do a dry run here as well. Let's do a dry run of this. Okay, let's do a dry run. Um, okay, here it's already there. So as you can see here, when you do factorial of 5, what happens? 5 into factorial of 4, right? Gives you factorial of 5, right? Now again, if you need factorial of 4, what happens? 4 into factorial of 3. So this process keeps on going until here. Until what is happening here? What is the base case we gave? Just remember the base case here. Factorial of 1, right? Factorial of 1, what happens? Factorial of 1 is what? After this, the recursive call is not happening. If you notice here, after this, the recursive call does not happen. It doesn't go to factorial of 0 or anything. It stops here, right? So that is what is the base case we give. Base case here, n equal to 0 should stop, or n equal to here n equal to 1 as well we give. All right. So here if you see, so this process just keeps going, right, until the 1 is reached, and then here it stops and prints the answer, which is 120 over here. Here this is how it happens. First 5, then 4, then 3, then 2, then 1. When the base case is reached, returns the answer, which is what we want, returns the answer there, and then goes back, right? That's how the output comes, right? Going down the recursion, keep reducing, goes up till 1, and then multiply the result. So this is how it happens. It's like a stack, you know. If you if you see if you see here, it works like a stack of books, right? So let us say you have something here. Uh, so like this, you have some. So like this, let's say this is like a stack of books. For example, let us say this is book A, book B, book C, D, and so on. C, D, E, and then F, right? All right. So you have so many books. So what happens if you remove first two books, the top two books? What happens if you remove them? I am removing this A, and also B. So what would happen in that case? What would happen if I remove A and B here? So this goes out, right? First A goes out, then B goes out. Now let us say it's outside now. First A goes out, and then B goes out, right? So B goes out. Now B is here, outside. So B you have, and A you have here, outside. So now you don't have these two, all right? Let us say you don't have these two now, for example, all right? Let us say you don't have these two. Now you have only these C, D, E, and F. Now you want to put these back. Now what is the first element when you remove this? It is C, right? Now if you put these back again, this B will go first. This B goes first inside, right? B goes first, and then after that A will go, right? So if I put it back now, if I put this back again now, then what happens inside this? If I just put it back, then I will have, then I will have, all right, let me just remove that. Let me just remove that line. All right, let's keep it that way. If I put this back, what comes first? B comes first. So B goes back in, and then again I have to fit A in. So what happens then? What happens then? I put A back here, right? So now, how did this happen? This is what is a stack, right? You just remove on top, like it's like peeling an onion, right? You just remove and then you put it back. So that's how the stack works. So that is a simple explanation of stack. So recursion also happens this way. Alright, that was just like an introduction to recursion. Uh, there is other things that this is a factor number program that we just did over here. That's what's given here. All right. So why stack overflow occurs? If the base case is not reached, not defined, the stack overflow can happen. We have explained all of that. All right. Okay. Um, so yeah, use a stack. That's what I explained now. Um, all right. So there is this Fibonacci program which we can do using recursion, which is very interesting. We'll look into that in the next live stream. If I do it everything today, it's going to be too much. So yeah, I don't think you have. Let's see if you have any questions. I don't think there are. All right. I hope you enjoyed watching this live stream. So tomorrow we'll continue with recursion. So until the next live stream, see you and bye.